All right. So again, these are the, so again here, okay? These are the, this is the definition of the trig functions, okay? And again, it's really just defined in terms of the length of the right triangle, you know, depending on what theta is. But this is how we define the trig functions here. Now, maybe not in this class because things are, you know, the tests and stuff are open book, but they have this thing called SOHCAHTOA. That's what you can use to remember the definitions of sine, cosine, and tangent. That's what you can do. All right, so we have this here. You know, we'll see later on that if you know the angle and you know one of the sides, you can get all the remaining sides, the two other remaining sides, that is. Okay, you know, that's what trigonometry you can do. Now, those are three of the trig functions. There's actually three more as well. We have these three: secant of theta, cosecant of theta, and cotangent of theta. I do define it here. These are the formal definitions. I know a much easier way to remember it. I mean, at least for me, it's a lot easier. They have what's called, well, I'll show you on the next slide. But this is what we have here. So this is how I actually remember the other trig functions, cosecant, that were on this definition, right? Secant, cosecant, cotangent of theta, like so. And you can actually prove these easily using the definitions. Cosecant turns out to be 1 over sine of theta. Secant of theta turns out to be 1 over cosine of theta. Cotangent of theta turns out to be 1 over tangent of theta. That's what these turn out to be. You can prove it easily using the definitions, actually. Although it takes a little bit of algebra. Well, not much algebra, actually. And in fact, tangent of theta turns out to be sine of theta divided by cosine of theta. It's really not that hard to show it, actually. And then cotangent is cosine of theta over sine of theta. Again, these are just some other identities. I mean, they're not the definitions. However, you know, for me at least, it's easy to remember these three trig functions: cosecant, secant, cotangent. Yeah. What's nice about these definitions, and really everything we've done, it doesn't matter if theta is measured in degrees or radians. It really doesn't make a difference. It doesn't make a difference. In other words, the definitions, the identities here, they're all the same. Now, since we have like 1 over stuff, you know, it's really good to know these, I guess, identities, you can call it. For any three numbers, A, B, and C, that are non-zero, 1 over that fraction, A over B, turns out to be B over A. So 1 over A over B is B over A. When you have 1 over something, that just means you flip it. You know, you turn it upside down, so to say. And then this is just from dividing fractions. A over C divided by B over C, right? A over C divided by B over C, that turns out to be the same as A over B. So the denominator C goes bye-bye. Okay, so it will be handy to know, it will be useful, that is, to know these. Again, A, B, and C here are non-zero, which makes sense, you know, you never divide by 0. Okay. Okay, now from here, there's something else I want to show with these. Namely, from this trig identity, if I'm going too fast, just let me know, I won't be upset. From this trig identity, you can actually get sine of theta as 1 over cosecant of theta. So cosecant of theta is actually 1 over sine of theta. So you get sine of theta is 1 over cosecant of theta. Same thing with secant and cosine. From here, you get cosine of theta is 1 over secant of theta. Tangent of theta is 1 over cotangent of theta. That's what we get here. Okay, so that's what we get here. Okay. And now, why is this true? Well, I give a proof of the first one here. You know, we know cosecant of theta is just the same thing as itself divided by 1, any numbers like that. And so from here, this really means that the first identity becomes this. The first equality, excuse me, becomes this. Now, when you have two fractions equal to each other, like so, you can cross multiply, and that equality is preserved. So this here equality implies this. You know, 1 times 1 is 1, and so we get this. And then from here, what do? Next? You just divide by cosecant, both sides. Okay? So you divide both sides by cosecant of theta, and you get this. Okay, so that's really, and the other equations here are proved the same way, in a similar way, that is. So it's not too bad. I figured it wouldn't hurt to present that because you'll see what I mean. It might come up later. And there's, of course, one more, one more, in fact, theorem here, Pythagorean's theorem, excuse me. And what's nice about this theorem is for a right triangle, you can actually get all 3 sides if you know the length of 2 sides, 2 of the sides, right? You know, if C is the length of our hypotenuse, if A is the length of one leg, B is the length of the other leg. You know, these 2 sides are legs. This side opposite the 90-degree angle, that's the hypotenuse. Okay. Then A squared plus B squared, right? That's equal to C squared. Pythagorean's theorem. Okay. That's what we get there. You know, it's very useful, as you'll see. All right. Are there any questions, though? Again, I'm sorry I made a mistake. I emailed the notes to the wrong class, so my mistake. Sorry about that. So people didn't have the notes in the beginning. So, okay. Again, if I'm going too fast, don't be afraid to say something. Okay. All right. So now we're going to solve these kinds of problems. Let's suppose we have a right triangle, like so. We know 2 of the sides, as you can see. And let theta be as here. We don't know what theta is, though, but it's another angle. First, what we're going to do is we're going to find the length of C, the hypotenuse, that is. We're going to find C, that's better. We're going to find that. And then we're going to get the trig functions at theta. Notice once we get all the side lengths, we can easily get the trig functions at theta. Right now, how do you get C, the length of the third side? Pythagorean's theorem. That's what I'm doing here. Right? You have c squared. Excuse me, you have c squared is 3 squared plus 4 squared, right? Or if you want, 3 squared plus 4 squared is c squared. Now c squared, okay, so 3 squared we know is 9. 4 squared we have is 16. So c squared is 25 then. 9 plus 16, which is 25. That tells us c is the square root of 25, which of course is just 5. So that's what we get there. So now that we know that side, we can get all the trig functions here.